Dear students, we have started the Unit 5 P block elements part 2. In that we have read about the boron family and the boron compounds that exist in the nature. Now the second family in the P block elements, group 14, that is carbon family and its compound. So today we are going to learn about the group 14 and its elements. So in this lecture the following topics should be covered. First you go for the group 14 that comes in the carbon family, the various carbon compounds and its properties including fullerene, that's the allotrope of the carbon having the structure buckyball. The carbides is the another category in the carbon compounds, and the fluorocarbons. What is the learning outcome of this lecture? The student will be able to understand about group 14 elements, that is carbon family, the various compounds of the carbon which exist in the nature, including the allotrope of the carbon, fullerene, its synthesis, what's the structure, properties and uses. The second compound, carbides, its classification, properties and examples. Then the third compounds, fluorocarbons, what is its preparation, properties and use. So let's start our carbon family. The group 14 is called the carbon family and includes its various elements: carbon, silicon, germanium, tin and lead. So what are the general properties of the carbon? As the carbon family having the 4 electrons in their outermost energy level. 2 electrons are in the S subshell and 2 in the P subshell. Only the carbon is having the S2 outer configuration, which is responsible for the differences between the carbon and the other elements in the family. So carbon has a different property from the other elements because of its electronic configuration. So as we move down the group in the carbon family, the radius, atomic radius and the ionic radius goes on increasing, and the electronegativity and the ionization energy in the group goes on decreasing. Atomic size increases moving down the group because the additional electron shell is added. This we all know. As we move down the group, the atomic size or the radius or the ionic radius, it goes on increasing because the addition of the electron shell goes on increasing, and the electronegativity and the ionization energy goes on decreasing down the group. The elements having the 4 electrons, so they have the ability to form the covalent compounds, though tin and the lead also form the ionic compounds. So having the 4 electrons in the outermost shells, they have the ability for the sharing and form the covalent compounds, though the tin and lead has the capability to form ionic also. Except the lead, all the carbon family exist in the different forms of allotrope. This is the important property in the carbon family, that only excepting the lead we have the other elements. We have a silicon, we have a germanium, we have a tin. They are having the various allotropes. The carbon, for example, exists in the various allotropes like diamond, graphite, fullerene and the amorphous carbon allotropes. Tin occurs the white tin, grey tin and the rhombic tin, and lead is found in a dense blue-grey metal. So except the lead, we have the various allotropes all the elements in the group 14. The group 14 has a carbon family elements having the higher melting point and the boiling points. Then the group 13 we have read the boron family. The melting and the boiling point in the carbon family tend to decrease moving down the group. So melting and boiling point as compared to the group 13, it is having very high in group 14, and as we move down the group, it goes on decreasing. It causes mainly because of the atomic forces within the large molecules are not so strong. Lead, for example, has such a low melting point that it is easily liquefied by a flame. It is having a low melting point. It easily goes on liquefying by a flame, and this makes it useful as a base for using as a solder in the mechanical purpose. So as we move down the group, the melting point goes on decreasing, which is responsible for the various application, as I have given the example of lead here. It is having low melting point, can be easily liquefied by a flame, which can be used as a solder purpose. So carbon family, as we have seen the elements in group 14, that are very important in our daily life as well as in the industrial level. It is a main basis for our organic life. Its allotrope, we all know the graphite is used in the pencils and the rockets. The various living organisms like proteins, plastics, food and organic building materials are all contain the carbon. Silicons, the another element which are a silicon compound which is having similar properties with the carbon is used to make the lubricants as well as for vacuum pumps. So it is having a application. Silicon is used as its oxide to make glass. Yes, glass is made as an industrial level by the silicon, silica, and germanium and silicon are the important semiconductors used in the various devices, and the tin and lead are used in the alloys to make the pigments. So we have a very important application of this family group 14. They are very important elements. So after understanding the carbon family, the group 14 and its importance with its properties, now we see the various compounds of the carbon. As we have learned, the carbon has a different property from its element because its ionization energy is high like the boron, and having the electronic configuration. So we have a variety of the compounds of the carbon. The first I'm talking about the fullerene, that is also called the buckyball. We all know the diamond, graphite, coal are the various allotropes of the carbon. The fullerene are the newly discovered allotrope of the carbon, and it is have been found to exist in the interstellar dust as well as in the geographical formation on the earth. They were unknown till 1985, and they are the large gauge spherical molecules with the general formula carbon 60, carbon 70 and 76, and it could be 80. It is 80. The most common fullerene existence as an allotrope is a carbon 60, which is also named as a Buckminster fullerene. Understood? So, because it was discovered by the scientist in 1985 and given the name Buckminster fullerene, which awarded the Nobel Prize in 1996 for its discovery of the fullerene. What is the synthesis process of the formation of this fullerene? We go for heating the graphite in the inert medium by supplying the high electric current in the atmosphere of the inert helium gas. We go for taking the medium helium gas by the high energy laser rays. So by this method, when we go for heating in the inert medium by passing the high electric current in the atmosphere, the high energy laser rays, we have the fullerene allotrope. Its structure, it's very beautiful structure we get of the fullerene, that is symmetrical structure, fused ring aromatic system, which can contain 20 pair of the hexagons and 12 pentabonds in the sp2 hybridized carbon atoms, which is called buckyball. It's a very beautiful structure of the fullerene. We have the pentagons and the hexagons, and it can be of 20 hexagons and 12 pentagons. In the carbon is in sp2 hybridized state, and that is the structure, symmetrical structure like a football. So that is called a buckyball, which is similar to. So what are the different properties of the fullerene? Fullerene are the good conductors of the electricity, highly chemically reactive substance it is. It reacts with the hydrogen to produce an unstable hydrocarbon. And here you are again able to see here the reaction with the fluorine to produce the fluorinated carbon. So they are highly reactive and react with the hydrogen as well as the halogens. What are the applications of the fullerene? It is used as an excellent lubricant because the balls can roll between the surface. So we can apply it as a lubricant. Alkali compounds of the carbon 60 are very superconducting materials. Even at the high temperature, we can use it of the order 10 to 40 Kelvin. So as an excellent lubricant, they can be used, and excellent superconducting materials, they can be used in these applications. The next compound we talk about the carbon is carbides. Carbon can form the compounds with the elements having lesser as well as greater electronegativity than itself. The compounds in which the carbon is combined with the elements of lower or about equal electronegativity are called carbides. So it can combine with any of the elements having the lesser or the greater electronegativity than the carbon, or it can combine with the lower or about equal electronegativity, specifically for forming the carbides. For example, calcium carbide, aluminum carbide. So let's understand a different kind of the carbide in the classification of the carbide. The first carbide is the ionic or the salt-like carbides of strongly electropositive elements of the group 1, 2 and 13 are the ionic substances. For example, the group 2, that is beryllium carbide. It is formed by the beryllium oxide when react with the carbon at the temperature, high temperature 1900 to 2000. That is, we have the beryllium carbide and carbon monoxide is released. Calcium oxide also form the carbon to form here the calcium carbide, which can be readily hydrolyzed in the water. So the ionic or the salt-like carbides, they are ionic in nature, and group 1, group 2 and group 13 when reacts with the carbon, such elements, they form such kind of carbides. Now we see the second type of the carbides, the ionic carbides which yield methane. The ionic carbide which yield methane on the hydrolysis. For example, beryllium carbide, aluminum carbide. when they go for hydrolysis. For example, when they react with the water, it forms beryllium hydroxide and the methane. So if they are on the hydrolysis producing the methane, such kind of the ionic carbides, they are called methanides. They are the ionic carbides, but on the hydrolysis specifically they produces the methane. So they come in the category of methanides. So the third category in the classification of the carbides are acetylides. Those ionic carbides which yield the acetylene on the hydrolysis. The second we have read the methanides which yield methane on hydrolysis, and those ionic carbides which on hydrolysis produces the acetylene. So here calcium carbide is an example of acetylide where it undergo the hydrolysis to produce acetylene gas. So this comes in the category of the acetylide. Next is the covalent hydrides, the carbides of the similar electronegativity, which are thermally stable and the high melting point and chemically inert solids, which is called silicon carbide or carborundum. So it's a covalent hydride. The next category is the interstitial carbide, the compounds of the carbon with the transition metals like titanium, tungsten, we have molybdenum. They are, if the carbon is combining with the transition elements, they form the interstitial carbides. So here the tungsten WC is the tungsten, zirconium, here the ZRC, molybdenum. These are extremely hard and the good conductor of the electricity. So these are the 5 types of the carbides we have seen. The first is the ionic or salt-like carbide, then methanides, acetylides, covalent hydrides and interstitial hydrides. Now the various characteristics and uses of the carbides we can have here. The tungsten carbide, which is used for cutting tools. It's an important application. Silicon carbide withstand under high temperature and it is used in the construction of the atomic reactor. It is called carborundum. So its different name of silicon carbide is a carborundum. Calcium carbide is used to prepare the acetylene gas, which is also used to prepare various kind of vinyl plastics, solvents, ethyl alcohol and acetic acid also. So there are various kind of the applications of the various carbides we have seen, covalent or ionic or acetylide or methanide. So here one more application is there, like boron carbide is used as an abrasive and as a shield as radiations. So we have seen the compounds of the carbon carbides. Now we are moving to the third compound, that is fluorocarbon. It is again an important category of the carbon compounds. When the fluorine reacts with the hydrocarbons leads to the formation of the fluorinated hydrocarbons, like you can see here, CH3F alkyl fluoride, CH2F2, C tetrafluorocarbon, CF4, here difluorodicarbon, C2F2, which is called fluorocarbons. So fluorocarbons are those which the hydrocarbons when react with the fluorine to produce fluorinated hydrocarbons, and fluorinated hydrocarbons are called fluorocarbons. So what are the different methods of the preparation of the fluorocarbon? The first method you can understand by the replacement of the halogen, except the fluorine, because fluorine is very highly electronegative in alkyl halides, by the fluorine atom in a metal fluoride. Like here except alkyl fluoride. Yes, and here the alkyl chloride is there. When react with the silver fluoride at a temperature of 25 degrees centigrade, we have AgCl, white precipitate, and alkyl fluoride. So alkyl fluoride is a fluorohydrocarbon, RF. It can be the preparation method, and the second preparation method is the replacement of the halogen atom by the fluorine atom in the anhydrous hydrogen fluoride, like carbon tetrachloride. It is there when react in the anhydrous medium of the hydrogen fluoride. It is the replacement of one chlorine atom, then one fluorine, it is added again to one chlorine atom more displaced. So by the substitution it goes from difluorocarbon, then we have a trifluorocarbon. All the chlorine get to replace CF4, and it goes on producing HCl, because Cl goes on removing by the replacement. So these are only called fluorohydrocarbons, and they are also named as freons. Understood? They are also called freons. So what are the different properties and the uses of the fluorohydrocarbons? Fluorocarbons are very stable compounds, and chlorofluorocarbons, which we have seen, which is derived from carbon tetrachloride by the replacement of fluorine atom by the fluorine atom, they are known as the freons. And difluorodichlorocarbon, freon 12, it is used in the refrigeration and the air conditioning phenomena in the place of the ammonia and the SO2, because of its important property, non-toxicity, and the non-inflammability. So we always use in such applications the freon. It is also used as a solvent for the DDT and other insecticides in the formation of the thermoplastic polymer, that is Teflon. It is mostly used, which is mainly used in the preparation of the utensils, that is tetrafluoroethylene. So this is all about the carbon family and the famous carbon compounds. In that we have discussed about the fullerene, that's the another newly discovered allotrope of carbon. Then we have carbides, and then we have understood about the fluorocarbons. Thank you and take care.